Hello and good afternoon, guys. I hope you have a wonderful week and great times in your life. Today and in here, I'm going to talk about how we can delineate a watershed using ArcGIS Pro version 3.4. And just to be mentioned, there is no difference between various versions of ArcGIS Pro 3.4, 3.5, 3.2, 3, 2.5, and other versions, since all of them have the necessary requirements in order to do this process. So before we enter to the methodology of how we can extract a watershed, first we need to understand the concept of it. So watershed or catchment area is an area that is topographically bounded, and it drains and collects all the precipitation through a common outlet, which we know as the pour point, and it can be river, bay, body of water, or like delta and etc., or various geographical conditions. So the limits of watershed is marked by the natural features such as ridges and hills, climate, mountains and cliffs. So that you understand, each watershed is divided by the elevation feature. We have to have the elevation data in order to delineate our watershed. So, and before that, we need to download our data. So there are various sources and platforms that we can download our DEM data. We can download it from USGS dataset, SRTM or Shuttle Radar Topographic Mission, ASTER dataset from NASA Earth Data, ALAS, Copernicus, Merit, and Open Topography, which each of them have the various spatial resolutions, and it depends on your purpose. You want to, I don't know, you just simply want to do a university project, you want to do a bigger project, you want to give a scientific paper, and you want to visualize your case of study, or any other purpose. It depends on that, or you want to model a runoff precipitation in HMS or flood modeling in HECRAS. It depends on you. So, but in here we just simply want a fine resolution, which SRCM with 30-meter resolution is fine. So after downloading our data from USGS platform, I'm just gonna enter my data over here, and as you can see here, this is a raster dataset, and if I click on each cell, it shows me a value which it indicates the elevation of that cell. And if I want to change how the visualization of this raster, I just have to right click on this layer symbology, and in here I have to change it. So if I click on show names and show all, it will give me the application of each color scheme, and as you can see here, it's selected. So first operation is going to be fill. What does fill do? Fill removes any peak or fills any sink. So in order to flow our water from each cell to other cells, I need to remove each sink, because it might save the water within that sink, or it might be blocked by that peak, so it might, I don't know, not let the that water to flow from various cells. So I need to use the fill operation over here and run it. I can put Z limit as well, but in here I do not need it, so I will leave it empty. My data has been filled, and as you can see here, I didn't have any peaks, but I have some sinks that have been filled. So this was the first order. The next one is going to be flow direction. Flow direction tells me how water in each cell it will be flow. So flow direction, I will enter my fill data, and as you can see here, there are three types of flow directions. I can select it, and if I push this information button, you can see the description of each algorithm. In the D8, it creates a raster which first imagine a grid cell which it contains 9 cells, 3 and 3 in each side. So in this grid, the center cell, if it runs through a single or the steepest downward slope point, it's d8. Like for example, this is 10, this is 11, this is 8, and this is 7. If it runs from this center cell towards 7, this is d8 algorithm. DINF or D infinity assigns a flow direction using the steepest slope of a triangular facet for each cell, and it's the best method for hydrological processes such as runoff and erosion. Like for example, this is 9, this is 8, and this is 7. It interpolates between these two and it runs through that interpolated line. So, and the MFD method goes to as many as steepest downward slope cells in the neighbor of it, so it can be many vectors. So I just want this d8. And the runtime, it depends on your GPU, CPU. So the stronger your PC or laptop is, the sooner we get the results. So I've just run it. Then I'm going to use flow accumulation. I do not need where exactly each of these rain and each of the drops of precipitation goes. I want the main rivers of my area, so I will just click this flow direction. There's you have to determine the flow direction type as well. I will run it here. It might take a few time as well. So before we run that, first we can use basin here as well, use the flow direction and run it here, and it shows the drainage basins of your dam here as well, but I do not need this. This is just simply a simple vision of how water drains in this area. I just want to have to delete it. So as you can see in the flow accumulation layer, the main river is shown right, and there are some sub rivers as well, but I want to give a condition to my rivers here, and it depends on the and various guidelines, but in here I just simply want to delineate all the necessary rivers. I'm going to use raster calculator. With raster calculator you can use any type of mathematical equation on your laser layer. I want to do mathematical condition, give a mathematical condition on this flow accumulation layer. I just put it, determine each of these flow accumulations that are greater or equal to 5,000. What does this mean? It means that determine if a cell can drain water of an area which is 5,000 pixels around of it. Like for it depend, we can go through the spatial resolution of your data as well. But for example, if this cell can drain an area about 5,000 cells, it will be determined as a river. If it does not drain an area with 5,000 cells, it's not my main river. So I will put it as my stream lines here. Run it. You can put various values and see how this function can be shown here. And then I'm going to orderize my streamlines. Stream order has to be here, so I'm going to add my streamlines, add my flow direction. There are two methods in here as well, stroller and stream. Stroller stream order only increases when the streams of the same order intersect. So it has a management vision towards these tributes, but Shreve orderize will be done by the magnitude of each streamline. So as you can see here, it can be mostly used for the modeling purposes, but I just simply want this roller method. So if I run it, you can see the ranks over here, different ranks and different colors. So, and since this is a raster format, I need to convert it for a better visualization in my output data. Stream to feature. This is the next operation. Stream to feature here. To use the stream flow direction, you can use the can use raster to polyline as well. And if I select this flow direction, run, as you can see here, my streamlines are now shown, and I can go to symbology here, use unique values, select grid code. And why did I use grid code? I will show you a little bit later. And I can use different with color palettes as well. Brown to dark. This one can be better. Yes. So the next thing I'm going to do is, first let me show you why I choose grid code. If I go to this attribute table, we can see each vector, data of each vector, and as you can see here, the grid code shows the ranking of each streamline, and I have used it here. So this was the purpose of my selecting my grid code in the symbology. So now I've extracted my streamlines. The next thing I'm going to do is determine the watershed area. So I'm going to go to tools. There is a watershed, but before that I'm going to create a feature class. Create feature class over here. I'm going to name it as the pool point 1 as my, this would be a point, and the coordinate system should be this. It runs, and then okay, so it run. So one of the methods is going to be using the using these snap pool point, which it automatically delineates my watershed in regard to that pool point area, which is defined by the flow accumulation. But I want to use the manual method, which is better, I guess. I have this watershed area already made, and I can see there is this over here, my pool point, which I want to do it manually. It has some errors, yes, but since I already have the understanding towards this area, I'm going to use it. The flow direction, and the next one is going to be pool point 1. I'm going to use this. I'm going to delineate it. Okay, save it. If it's saved, okay. So my watershed run. So as you can see here, my watershed is already extracted, and if I show you, as you can see here, there are some parts that are not covered. This is why I had to download this swath, this and this one, but I want to just do the simplest way, so I just have this point as my pool point, and this is totally fine. The next thing I'm going to do is that convert this raster data towards the polygon, which is another vector type. Input raster is going to be watershed here, and okay, and my watershed is already defined. So I'm not going to need this the other types of, no, let me just go through this one. Yes, here. I'm not gonna need other stuff, but I'm going to need some things over here. I'm going to just need this. I don't need this one. I don't need this one too. So I definitely don't want this as an output. I cannot show this in my project paper or anything else, so I want to make a better visualization from it. So the first thing I'm going to do is clip. What does clip do? It clips and it outputs all the features within the desired area. I'm going to use this raster watershed here. Features are going to be well, why is not this one's not here? No, I'm going to streams and raster over here, run it, and as you can see here, it shows only the streamlines within this area. I'm going to delete this, I don't want it. Then I'm going to use raster clip raster over here. I'm going to use this TIFF output extent. It's going to be my watershed area. Use this input feature for clipping geometry and maintain clipping extent. I definitely tick these buttons, and no data values should be 0. Run it, and then it's exported here. I'm going to show you, yes, it's exported. So the next thing I'm going to do is I have to delete this one, change the visualization of this. Let me use one of these elevations here. So, and then I have to go to symbology, go to here, transparency, reduce it, and yes. Or if you didn't want your watershed area shown, you can just simply use this stem. There's no difference actually. So what I'm going to do next is that I'm going to first, let me just clip these backgrounds, find a perfect extent for this area. So I just this is good for me for now. Go to map, go to bookmarks, go to bookmarks, new bookmark, click OK, and this output is saved in your bookmark, as you can see here. So before that, this was somehow a long process. If you didn't want to repeat it multiple times, you just have to click model builder here, add your data over here, add the functions, like for example insert from toolbox here, analysis tools, like fill over here. I have to just click it on over here, and then image surface raster just as is, and repeat all the functions for this until you create a full flow chart from inputting a dem, filling it, and creating a flow direction, accumulation, features, stream order, watershed, and etc. So this was a model, and you can easily save it over here. Then you wanna model builder, save it over here and use it whenever you want it. So this was the model type here. But I'm going to visualize my data. I'm going to your new layout. It has various port sizes. I'm going to need an A4 is here. So I created. The next thing is going to be map frame. Add my data. As you can see here, it might not meet my features. Let me just delete this and use the other one. I think that the other one is more better. Yes, it's much better. So you can see it doesn't fit the frame, so I'm going to make it smaller, and then I'm going to show you what I want to do here. I'm going to use this layout. I'm going to activate. I'm going to put it over a little bit here, since I'm going to need this. So the next thing I'm going to do, first let me just change these to a streamline, and this I don't want this. I want this to be named as dem, so, and etc. So I can easily click on these two. I don't want. So the next thing I'm going to do is that to add the various elements. It's just like the charts in the Excel. I have to add my various elements towards it. So I'm going to use this one here for my north and west and delineation. So I'm going to add certainly a legend for my data here. What you can see is a little bit messy over here, so I'm going to need this to be only named as the layer name and grid code. Yeah, a little bit higher. A little bit higher again. So it's a little bit messy, so let me just try another one. Yes, this would be much better. Yes, no. You find and select which one is more proper for your data. I'm just gonna, yeah, let me just stick with the first one here. You can just simply add the activation type over it. No, I shouldn't click on it here. 0, put it on 0. So, and I'm gonna go to streamline, properties, headings. Don't want this. I want to be just like this. So yeah, that's it. And delete this one as well, since I'm not gonna, well, no. If you want, you can delete this one as well. I don't think, no, it can be done. So leave it, we'll leave it just like this. And them is like that too, and you can easily export it. It's a little bit messy, guys, I know, and I'm sorry, but you can create a little bit better. It depends on your creativity. It depends on your how do you want to visualize your data. You can easily create charts, create tables, and etc. And from here, share, you can export your layout to PDF, GOT, or other types of file formats. But I think PDF is much better. So we can use print layout, and yeah, here as well. And I hope this video was useful and practical for you and for your projects and studies. And I'm very, very pleased that you've watched so far until now. Thank you very much. I hope to see you again. Until next time, take care.